Hi, it's Allison from East Cobb Tutoring Center, and we are going to graph y equals sine x and y equals a sine bx, which will change the amplitude and the period of the graph. So let's start with the parent graph, and we are going to make a t-table to show some of the important values from the unit circle. We're going to begin by graphing in degrees, and then we will add in radians in just a little bit. So I'm putting on kind of the big important angles from the unit circle. These are all the ones on the axes. So the sine of 0 is 0, the sine of 90 degrees is 1, the sine of 180 is 0, then -1, and then 0 again. So on the coordinate plane here, I'm just going to graph my points. Now the method I'm going to show you is going to work regardless of what the period and amplitude are. So the first thing we do is we find the amplitude. For the parent graph, it is 1. And we mark the top and the bottom. Then we go to the end of the period. The period is 360 degrees, which is one trip around the unit circle. We mark half of that, we mark half of that, and we times this number by 3. That gets us 270. Sine starts on the origin, and then we just plot the points from our t-table. It's a little bit hard for me to see my graph paper. It's really light on my screen. And then just connect the dots. So what I've graphed here is one period for the sine graph. Now we are going to do a transformation. And let's choose a new equation. This time we'll do y equals 2 sine 3x. The first thing you want to do is identify the amplitude and period. The amplitude in this problem is 2. That's the number here. And the period is found using this number 3. The period is not 3. The period is 360 degrees over b. So because b in this problem is 3, the period is 120 degrees. So remember the method we did earlier. We don't need another t-table for this because we're going to just reuse the pattern. The top of the amplitude is 2. Here's the bottom, -2. We find the period on the graph. My graph paper is counting by 30s, so 120 is right here. Then we do half of that, that's 60. Half of that, 30, times that one by 3, 90. So the period, half of that, times it by 3. And now we just sketch in the shape of sine. Sine starts on the origin, then goes up, middle, low, and back. I did a pretty good job of saying on my graph paper there. Okay, so now let's take a look at some examples in radians. And I'm going to change my graph paper. There we go. Oops, looks like I changed back to degrees. There we are. Okay, so let's jot down the parent graph again. Now we know the general shape, so we don't need to worry about making another t-table. So the amplitude is 1, -1, and the period in radians is one trip around the unit circle, or 2 pi, half of that, times it by 3. And then sine starts on the origin, up, middle, low, middle. All right, so now let's do a transformation on this by changing the amplitude and the period. Let's do y equals, and this time let's give ourselves a negative number in the front, -3 sine 2x. All right, so the amplitude here is not -3, it's just 3. That's a stretch. And then the negative does something else. That's a reflection. We'll talk about that in a minute. For the period, instead of doing 360 divided by b, we're going to do 2 pi divided by b because we're in radians. So 2 pi over 2. So the period is pi. Oops, there we go. All right, so watch how I graph this thing. Just like we did before, I'm going to mark my amplitude, which is 3. Here's -3. And then I'm going to go to the end of the period, which is pi. There it is. Half of that, half of that, which, let's see, that's pi over 2, so I guess pi over 4 would be right here. And then times that one by 3, which will put me here. All right, so sine starts on the origin, which puts us right here. But remember, we have a negative in the front. That's a reflection. So instead of going up with my first point, I'm going to go down. So that's going to put me down here. So I'm going to go down, middle, high, middle. All right, so there we go. That's one period of our sine graph. You could just repeat the pattern if you needed to. Some teachers prefer to see 2 periods, which would look something like that if we had to keep it going. I hope that helps, and we will graph cosine in another video.